All right, ladies and gentlemen, welcome to the very first day of Math B. We are going to go ahead and talk about the properties of exponents. Now, these properties are something we're going to take a look at with some of them, the others we're just going to have to know. One of the ones we're going to have to know, for example, is just a to the 0, or anything to the 0 power. Anything to the 0 power will always be 1. 4 to the 0 will be 1. 2 to the 0 will be 1. 1,247 to the 0 will be 1. If you don't believe me, go ahead and pause this video real quick and check it. Alright, I assumed you just checked in a calculator. Next, we're going to talk about the property of multiplication of the same bases. Now, when you multiply by the same base, something special happens to my exponents. So a base would just be the same number. So say we had x squared and x to the third. My base here would be the x's. I'm going to jot that out there for you. Those are going to be my bases. We should know that the 2 and the 3 are the exponents. Something we've seen before, we've talked about it a couple times. We know that anything squared is that number times itself. For example, say we had 3 squared, we knew that 3 squared was 3 times 3, which is just simply 9. Okay, now that we've refreshed our memory here a second, let's go ahead and get rid of this. I want to take a look at working more with those exponents. So again, we know that anything squared is 2 of them. So I'm going to expand this expression here. Now remember, expression is something is not a formula. So I'm going to take that x squared, I'm going to take x times x, because we just talked about that's what it means, times 3 more x's, because I'm taking that squared times the cubed. Squared is 2, cubed is 3. Now let's take a look at how many x's do I see here now. I see a total of 1, 2, 3, 4, 5. Well, that's going to give me an x to the 5th. Just like when we said x squared, let me grab a different color. Just like when we said x squared was equal to x times x, there's 2 of them. I'm not going to continue to expand anymore. I want to simplify. So now that I know I have 1, 2, 3, 4, 5 x's, that's how I get my x to the 5th. Anyone notice anything special about that? If so, fabulous. You catch on real quick. If not, let's take a look at another example. Let's take a look at y to the 3rd times y to the 7th. If we expand that out for a second, I have 3 y's. Now remember, I don't need to add in those dots if I don't want to. Remember, any variables just touching right next to each other with no operation sign being seen is just multiplication. And that's going to be multiplied by 7 more. 1, 2, 3, 4, 5, 6, 7. Let's take a look at how many y's do I have. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 y's. So that must mean that I have y to the 10th. Let's try this now with a numerical example instead of just variables. So say I had 2 to the 2nd times 2 to the 3rd. If I expand that out just as I had expanded my x's and my y's, 2 squared is 2 times 2. 2 to the cubed, or 2 to the 3rd, is 3 more 2's. How many 2's do we have together? I've got 1, 2, 3, 4, 5. So my resulting answer is 2 to the 5th. Or if I grab out a handy dandy calculator, that is simply just 32. Let's take a look at making a conjecture about what we've just talked about. So we had x cubed times x squared, and that was x to the 5th. Then we had y to the 3rd times y to the 7th, and that was y to the 10th. Then I had 2 squared times 2 to the 3rd, which is 2 to the 5th, which ended up being 32. Do you guys notice something happening between all of my exponents? Some mathematical operation? If so, fabulous. You're a genius. If you haven't gotten there yet, that's okay. Essentially, if you have the same bases, in this case I'm going to use an example of a, and you have it say a to the n times a to the m, when you have two bases being multiplied with two different exponents, you just take your exponents and add them. That's what we did in all three of these examples. I'll give you a second to take a look on that. Next, what we're going to go ahead and take a look at is looking at when I have, say, the example x to the fourth over x squared, what my answer is going to be. Well, again, we know that by the properties of exponents, on top I have 4 x's, on bottom I have 2 x's. Recall for a second with me that if I have the number, say 3 over 3, don't my 3's just cancel out and give me 1? Or maybe 2 over 2 gives me 1? Or 6 over 6, oops, that's bad, 6, gives me 1? Anything that matches the top and the bottom end up just canceling out. Well, the same thing happens when I'm dealing with any kind of base. So if you take a look, I have 1x on top, 1x on bottom. Those are going to end up canceling each other out. I have another x on top, another x on bottom. They're going to cancel out. So my final answer for this first example will end up being x squared. Again, when we're going through these examples, try and figure out if you can find the mathematical property that is going along with these, that is going along with my examples. So now let's take a look at y to the 7th over y to the 4th. Well, if I expand that out for a second, I have 1, 2, 3, 4, 5, 6, 7 y's over 1, 2, 3, 4. Again, I'm going to try and find a buddy for 1 y on top, 1 y on bottom. Oh, I've got one. They're going to end up canceling each other out. Hey, look, I found another one. Gah. They're going to end up canceling each other out. Another one. Boop, cancel. Another one. Boop, cancel. So my resulting answer is y to the 3rd because I end up having 3 y's left over. Now let's try this with a numerical example. What if we had 2 to the 5th over 2 cubed? Well, again, 2 to the 5th is 5 2's. And this time I need to put those multiplication dots in there or else it looks like a really big number. Over 3 2's being multiplied. Just like before, I'm going to find a buddy and cancel it out. Find a buddy, cancel it out. Find another buddy, cancel it out. So here are my final answers, 2 times 2, or 2 squared, which is equal to 4. Let's try another one. What if I said I had 3 to the 7th over 3 to the 4th? 1, 2, 3, 4, 5, 6. Ooh, what's my pen doing? Hold on 1 second. Momentarily error. 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4. Well, let's find those buddies and do some canceling. Cancel, cancel. Cancel, cancel. Now, it doesn't matter where I grab my buddies. Nope, my final answer will be the same. So if you take a look, you should have 1, 2, 3 x's left, or 3 3's left, which will give me 3 to the 3rd, which is equal to 27. So again, let's see if you guys have stumbled upon an aha moment and discovered what's going on here. Well, I'm going to tell you what's going on. In all of my examples, when I end up dividing my common bases, say I'm going to have a to the n over a to the m, what I end up doing with those exponents is I simply subtract them. So do I really have to expand these? No. I was expanding them to show you what actually happens with my properties. All right, the rest of your time is to work on your homework.